Okay. Good morning, all of you. Today we will discuss continuity for yesterday class. We are discussing about some special characteristics of electrode potential. So this is also very important point. You see carefully. Metals which are having low electrode potential can replace metals from other compounds which are having high electrode potential. Did you understood this statement? Metals which are having low electrode potential can replace the metals from other compounds which are having high electrode potential. What is the meaning of this one? First we have to understand why low electrode potentials can replace high electrode potential metals. In case of metals, what I told, reactivity is inversely proportional to electrode potential value. So out of these two, the taking metal is low electrode potential. Low electrode potential means highly reactive. That's why it has a capacity to replace the metal from its compounds. For example, I will give you two equations for understanding. Cu plus ZnSO4 I given amount. Okay, one more thing I am giving zinc plus copper sulfate. This is a very nice point actually. Both are going on or anyone is proceeding. Why? I am telling this reaction will not give any products. But here we are getting some products. What we are getting? Copper replaced by zinc means we are getting zinc sulfate plus copper we are getting. Why? That is our statement. Okay, what is the electrode potential of zinc amount? Minus 0.76. What is the copper electrode potential value? Plus 0.34 volts. Yes, zinc has capacity to replace the copper because it is a low electrode potential, high reactive. Can replace, but here replacement is not possible. Why? Because the copper is having high electrode potential. High electrode potential value. This part it won't participate in the chemical reaction. Did you got it? I will give you one more question. Same concept. For example, if you take nickel and or otherwise you can take zinc and silver. You can take zinc and silver AgCl, and we can take Ag and ZnCl2. What reaction will be proceeding? Which reaction will be proceeding? Yesterday already given some information related electrode potential value minus this is 0.76 but this is 0.8. What happening? First one will be proceeding. Yes, because this zinc has low electrode potential, more reactive, that's why has a capacity to replace the metal from other compounds. Okay, that has relatively having high electrode potential. Then we have to take 2 moles here. Then we are getting ZnCl2 plus 2 moles of the silver. But here no product. Because high electrode potential value cannot displace the low electrode. Low electrode can displace the high electrode potential from its compounds. All of you clear? Yes. I will give you one more important statement. Metals which are having a negative electrode potential value can liberate hydrogen gas from acids. Very nice point, Amma. The metals which are having negative electrode potential values can liberate hydrogen gas from the acids or reaction with acids. Just I will give you one thing. Copper plus H2SO4. I given one reaction, and zinc plus H2SO4. Both are proceeding or any one, and why? Second one only will be proceeding. First one will not give any products based on electrode potential value. Why? Because zinc has minus 0.76 volts. Here hydrogen is there. Electrode potential value will be 0. Anyway, compared with hydrogen, zinc is negative value. Negative value is more reactive. Means low. Low means highly reactive. Highly reactive means involving in the reaction with H2SO4. Then what we are getting? Zinc sulfate we are getting. Actually from here we are getting H plus plus SO4 2 minus. The 2 H plus particle will undergoing reduction. Why? Because 0 minus low electrode potential oxidation. Zinc undergoing oxidation. The liberated electrons is received by H plus is becoming like hydrogen. If you take for example silver plus H2SO4 will not give hydrogen gas. The metals who are having negative electrode potential, they are highly reactive for oxidation. Automatically the liberated electrons will be taken by hydrogen H plus particle and becoming like hydrogen gas. The nice computative information this one. Okay, all of you clear? Now I will explain further concept. This is the concept for 5 moles. The derivations is not required, but the formula is important for solving 5 moles questions. What is that one means? Nernst equation. Nernst equation. We are deriving formulas for 5 moles problem. Okay, here 1 plus 2 plus 5, 8 moles weightage is there. What is the Nernst equation? Why we should learn it? Nernst is one of the great scientists in whole chemistry and as well as in electrochemistry. What he did? He given relationship between electrode potential values and corresponding concentration of the metal ions. Concentration of the metal ions indirectly is nothing but concentrations of the solutions. Did you got? So he tried to give the relationship between electrode potential values and concentration of the metal ions indirectly is nothing but concentration of the solution. How we derive the relation, I will explain. Please be careful. He is taking one electrode reaction M plus N means metal ions. He is receiving N number of electrons, is becoming like a neutral metal atom, which are in aqueous medium. Metal ions are in aqueous medium. After receiving electron like Cu plus 2. After receiving electron is becoming like a solidify. Okay, he taken one electrode reaction then he proposed Nernst equation for this reaction. E means what? Electrode potential is equals to E naught. Standard electrode potential minus RT by NF into log ln of, not log, ln of means products by reactant means is nothing but concentration of the metal solid by concentration of the metal ions or in which medium? Aqueous medium. This is not final conclusion. You have to simplify, then you will get the conclusion how electrode potential is interlinked with concentration of the solution. Electrode potential is equals to standard electrode potential minus RT by NF into ln of concentration of the metal by concentration of the metal ions. Okay, I want to simplify here. Let's check it first here. What are the terms here? R means what? Yes, very good one. Universal gas constant. Do you know joule value? R value is different based on units of pressure and volume is there. Yes, very good one. 8.314 joules, Kelvin inverse and mole inverse. MKS value. Okay, what is the T? Absolute temperature. What is the meaning of absolute temperature? Temperature should be expressed in kelvins. Generally, we are doing all reactions at room temperature. Room temperature is nothing but 25 degrees Celsius. It is nothing but plus 273 is nothing but 298 kelvins. What is the N? Yes, you can tell from by seeing the above equation. N is what? Whether gained electrons or loosed electrons. That only we are telling transferred electrons. Transferred electrons either in oxidation or reduction. And what is the F? Yes, this is important word. It's not force. F means what? In electrochemistry, F means it is nothing but Faraday. What is the Faraday? 1 Faraday is equals to, do you know charge? 96,000, sorry, actually 95,000, 95,000 something will be coming up, but around if you can do it, 96,500 coulombs charge. 1 Faraday is equals to 96,500 coulombs. What is this? How you got this value? 1 Faraday is nothing but a charge on 1 mole of electrons. Okay, what is the charge on 1 mole of electron? 1 mole of electron means how many particles? 6.023 into 10 to the power of 23 into. Every electron carries some charge. Yes, very good amount. 1.602 into 10 to the power of minus 19 coulombs. You simplify whenever you are free, you will get this answer. 96,485 or 486 something will be coming, and you are taking around round figure 96,500 coulombs. Nothing but Faraday. You got all the values here. So what is the electrode potential from the Nernst equation formula? Electrode potential is equal to standard electrode potential minus RT by NF into ln of concentration of the metals by concentration of the metal ion. Still, I want to simplify something here. Take one more time the same equation. Electrode potential is equal to standard electrode potential minus RT by NF into ln of concentration of the metal should be in solid phase by concentration of the metal ions taken in which medium? Aqueous medium. Okay, in this whole equation, one term is becoming 1. In all these terms, one of the term is becoming 1 according to chemical equilibrium. Did you study or no? Pure solids concentration or pure liquids concentration should be taken as 1. If you take an aqueous medium, gas medium, you have to consider it. But pure solid, if you take CaCO3, its concentration should be remains constant. If you take alcohol, pure alcohol should be taken as constant. Like the pure solids and liquid concentration term should be becomes 1 according to equilibrium concept. According to the concept here, what happening? Metal particle which are in solid phase is becoming 1. Substitute in the previous equation. Electrode potential is equals to standard electrode potential minus RT by NF into ln of, very good, 1 by concentration of metal ions are in which medium? Still, I want to simplify this one, just you check out it. E is equals to E naught minus RT by NF into ln of 1 by x power minus 1. Can you write it down? So, concentration of the metal ions whole power minus 1. Is there any problem? No. Okay, again, you have to use one more formula. Log A power x log A. So, minus 1 comes friend. Then E is equals to E naught, the minus into minus becomes plus RT by NF into ln of concentration of the metal ions. What formula I applied here? I will write here in bracket log A power x is equals to x log A. That's very simple, already we used several times. Okay, still I want to simplify here. We can write ln is equals to something from chemical kinetics. Yes, very good amount. 2.303 into log. ln means to the base e, log means base n. Can we substitute in the previous? Yes. You take it and substitute here. What we are getting? E is equals to E naught plus RT by NF into 2.303 into log concentration of the metal ions. Are you getting? So, in this equation, some of the terms is common for all electrode reactions. Anybody? R is constant. Temperature is also room temperature constant. 25 degrees is nothing but 298 kelvins. For all electrodes, 2.303 also constant. And one more is constant. What? Faraday is constant. Substitute all the values. What are the values? RT into 2.303 by F. Indirectly nothing but 8.314, temperature 298 into 2.303 by Faraday 96,500. Simplify all the values, so you are getting one common simple number 0.059. Instead of all these rounded numbers, calculate 0.059. Yes, to do it you will get it. Electrode potential is equals to E naught plus 0.059 by N into log concentration of the metal ions. This is the formula for electrode potential from the Nernst equation. What is it? electrode potential is equals to standard electrode potential plus 0.059 by n into log concentration of the metal ions. Here n means what? Number of transferred electrons. It is oxidation means loosed electrons. If it is reduction means gained electrons. It has to be mentioned. From this, can we tell what is the relation between electrode potential and the metal ions? Indirectly nothing but concentration of the solution. What is the relation? Directly proportional. Yes, we have to tell that point only. Finally, we can give the one conclusion. We have to remember electrode potential is directly proportional to concentration of the metal ions is nothing but solution, because some value we are getting. So we have to remember to solve the problem, electrode potential of any electrode is equals to standard electrode potential of that metal plus 0.059 by n, nothing but number of transferred electrons, whether loosed or gained electrons, into log concentration of the metal ions, nothing but concentration of the start solution. Okay, now from this I want to get one more formula, is nothing but EMF of the cell. EMF of the cell is denoted by E cell. Okay, just you imagine one equation, Daniel cell equation. Later we can write common equation, Daniel cell. What the Daniel cell? You did know. Initially zinc will be there. It is in which form? Solid form. Plus Cu plus 2 is in which medium? Aqueous medium. Yes or no? Then zinc is becoming oxidized. Zn plus 2 goes in aqueous medium. Cu plus 2 is undergoing reduction, becoming like Cu solid. Is it clear? Okay, now first of all I am taking electrode potential of the zinc I am taking, or otherwise we have to take electrode potential of the copper. From first next equation, what should be written? Electrode potential of any metal rod is equals to standard electrode potential of that metal rod plus 0.059 by n. N means what? Yes sir. In the copper what happening? Plus 2 is becoming 0, means change electrons 2. Okay, otherwise no sir, I will take oxidizing. We have to take that one also. We will get how many electron change? 2 electrons. That's why it is becoming like 2 into log concentration of which ions has to be taken? Copper plus 2 ions has to be taken. Is it clear amount? Same thing write down from the next equation. Electrode potential of zinc is equals to, yes sir, standard electrode potential of zinc plus 0.059 by 2 into log concentration of the Zn plus 2. Indirectly copper means considered as a cathode, zinc means considered as a anode. We want which one among? EMF of the cell. What is the EMF of the cell formula? EMF of the cell is equals to electrode potential of cathode minus electrode potential of anode. Indirectly, electrode potential of cathode means what is here? Copper minus electrode potential of anode means zinc. Just to simplify, EMF of the cell is equals to copper value E naught of copper plus 0.059 by 2 into log of concentration of the Cu plus minus zinc. Zinc means what? Electrode potential of zinc minus into minus is becoming minus into plus minus no into what is coming? 0.059 by n into log concentration of the Zn plus 2 ions. Okay, I want to separate them like two sets. EMF of this cell is equals to, this is like a one set. Right now, standard electrode potential of copper minus standard electrode potential of zinc is the one set. Okay, now I want to take this is one another term, this one and this one. What can be taken common? Yes, 0.059 to take it. Otherwise, I am taking for my convenience, you can understand that I am taking minus of 0.059 by 2, I am taking common. Then what is coming? What is coming first? Log of concentration of the Zn plus 2. Then minus of minus no. Then log of concentration of Cu plus 2. Oh, so EMF of this cell is equals to, what is this one? Standard electrode potential of copper cathode minus standard electrode potential of zinc, nothing but anode. What is that one? EMF of the cell only, but standard EMF of the cell. Then we are getting E naught cell, we are getting standard EMF of the cell. Okay, minus of 0.059 by 2 into log. Formula we can use. Yes, log A minus log B. Log A by B means we are getting Zn plus 2 particles by which particles we are getting? Cu plus 2 particles we are getting. So I can write this one like a one common formula. Yes, just you check it. EMF of the cell is equals to standard EMF of the cell minus 0.059 by always 2 will come. In this 2 will be coming, but it may be 1, 2, 3, whatever it is. That's why we are taking like a common number n into log. Zn plus 2 means is it products or reactants? In the cell reaction, Zn plus 2 means products and Cu plus 2 means reactants. So what can be written here? Log of concentration of the products by concentration of the reactant. This is the formula for EMF of the cell from Nageswara equation. EMF of the cell is equals to standard EMF of the cell minus 0.059 by n into log concentration of the products by concentration of the reactant in the cell reaction. Here n means what? We can write it. N is equals to number of transport electrons. Transport electrons. Did you got it? All of you? Yes. We will work out some other concepts related to this one. Once again I am telling derivations is not required, but final conclusions is important. So what is the electrode potential formula? Electrode potential of any electrode is equals to standard electrode potential plus 0.059 by n into log of concentration of the metal ions, nothing but solution. So from this we can tell electrode potential is directly proportional to concentration of the solution. That's why already I told electrode potential value depending upon the nature of the metal and temperature and as well as concentration of the solution. Already I told, we proved that one. Now I will explain some other things. EMF of the cell is equals to standard EMF of the cell minus 0.059 by n into log of concentration of the products by concentration of the reactants in the cell reaction. Just I will give you some examples you have to understand. From this I will give you something. Okay, for example, I am giving Ni plus Ag plus gives rise to Ni plus 2 plus Ag. Write down EMF of this cell reaction for this cell reaction. Observe carefully. Don't take blindly. What happening? Ni is becoming Ni plus 2 means change in electron will be 2. But here given Ag plus is becoming Ag. Right now it is taking only 1 electron. It's imbalanced. Should make it balance first. How? Yes, very good. That's enough. 2 Ag plus is becoming 2 Az. Each Az taking 1 electron, then 2 Ag particle is taking 2 electron balanced. How many produce? That many has to be utilized. Okay, now number of transport electron either in oxidation or reduction is nothing but how many? 2 electrons. Problem is solved. Now we can apply this one. EMF of this cell is equals to standard EMF of this cell minus 0.059 by 2 into log concentration of the products. So you can understand very clearly. Pure nickel solid, pure silver solid. Always pure solids and liquid should be unity. Okay, now these are in aqueous medium, so we have to consider only aqueous medium chemical concentration. Right down here. Concentration of Ni plus 2 by concentration of Ag plus. That's it. Yes, very good. According to equilibrium concept, what is the one more point? Whatever coefficient is there, it is as it is coming in its powers. That's why we have to do this one. 99% of the student doing mistaken only. They are not considering a square. Then problem will be goes wrong. You have to understand, yes, sir, this is the products by reactant concentration is related to equilibrium. That's why whatever coefficient is there in the balanced equation, it will be goes as it is in its forms. All of you clear? Yes. Now I will give you one more equation for example this one, or otherwise if you understood, no. Yes. Now I will tell you one more thing. It is nothing but equilibrium constant. Equilibrium constant from the electrode potential values or EMF of the cell. Equilibrium constant is denoted by Kc. Okay. If you take the cell reaction, what happening? Zinc plus Cu plus 2 is becoming like Zn plus 2 plus Cu will be coming. This is calling as a oxidation. This is calling as a reduction. Both are going on in the cell. At a particular state, rate of oxidation is equals to rate of reduction at two electrodes. That state only we are calling as equilibrium state. Okay, whenever rate of oxidation is equals to rate of reduction in that cell reaction, some values will become equal. Anybody? You taken zinc rod in zinc sulfate amount, you taken copper rod in copper sulfate, you given connection, power generation is going on. After some time what happening? Rate of oxidation is equals to rate of reduction. That state only we are calling as equilibrium state. At that equilibrium state, some values will become equal, not rate. Other than this, one more value will become equal. Concentration, sir? No. At that equilibrium state, what happens means electrode potential of copper is equals to electrode potential of the zinc. Why? The speed of liberation is equals to speed of the consumption. Then what happening? There is no potential difference between cathode and anode. Means E of copper is equals to E of zinc. Automatically what happening? EMF of the cell means E of cathode minus E of anode should become. That's why in the previous equation, what is the previous equation? EMF of the cell is equals to standard EMF of the cell minus 0.059 by N into log concentration of the products. It is nothing but Zn plus 2. Sorry, yes, no? Zn plus 2 by which one? Cu plus 2. But we can tell at equilibrium state. At equilibrium state, rate of forward is equals to backward, then electrode potential of cathode is equals to anode, then there is no power generation because EMF of the cell is becoming 0. Already I proved that one. EMF of the cell is becoming 0. Can we substitute this one in this one? Yes, then what is coming? 0 is equals to standard EMF of the cell minus 0.059 by N means how much amount? 2 no, commonly here coming 2 no, into log concentration of the Zn plus 2 by concentration of Cu plus 2. Simplify. This negative term on this side. Standard EMF of the cell is equals to 0.059 by 2 into log concentration of the Zn plus 2 by concentration of Cu plus 2. Again one more thing I am writing. Standard EMF of the cell at equilibrium state is equals to 0.059 commonly by N for these two, but commonly we are writing N into log zinc ions. Is it reactant or product? Products. So concentration of the products by concentration of the reactant. Already we know equilibrium constant Kc is defined as the product of concentrations of the products by product of concentration of the reactant. Nothing but concentration of the product by concentration of the reactant. Can we substitute in the previous Kc? Yes. Standard EMF of the cell is equals to 0.059 by N into log Kc. Third formula we derived. For the first formula, electrode potential is equals to standard electrode potential plus 0.059 by N into log of concentration of the metal ions or nothing but concentration of the solution. Second formula, EMF of the cell is equals to standard EMF of the cell minus 0.059 by N into log concentration of the products by reactants in the balanced cell reaction. Okay, at equilibrium position, what is the formula? Standard EMF of the cell is equals to 0.059